Hello, friends. Happy to be with you here today. Going to jump into Daniel Liang's Introduction to Java Programming. Today, recursion. And recursion is absolutely fascinating to me because it's extremely efficient for the programming side. Now, it absolutely eats the lunch of the computer side. We'll talk about that more later. I thought a fun place to start out would be inside of section 2, where Daniel introduces a case study on computing factorials using recursion. So what I wanted to share with you, let's go ahead and get started. Let's make a new Java project, and I'm going to call this Liang Chapter 18 Listings. Use the default Java runtime environment. Finish that. Now, because I don't have the workspace I'm in as a GitHub repository, I'll share this project with my GitHub repository, and we'll do that. And pop over here right quick. Actually, I don't have my terminal open, so I'll just do that right quick. I'll CD to where I have everything stored. Listings. And you can see that we've got chapter 18 started, and I'll just go ahead and push that up to the cloud. And it's got my credentials cached from the last time I was playing with this. Okay, so now we've got Eclipse, and we can come in here, and I'm going to make a new package, a folder to keep our files in, and I'm going to call this chapter 18 listing 01. Now inside that, I'll make another class of the same name, but this way I don't have to worry about sharing classes with anything else. So I'll call it chapter 18 listing 01. I am going to include the public static void main, so this is executable. And one of these days, I'm going to forget I'm going to forget my superstition, and I'm not going to do this. And on that day, it's the universe is going to laugh at me, and the universe is going to say, by the way, did you know that I wouldn't even ran even if you had done that? Something else has gone a little bit wrong. So let's go ahead and let's come look at this. Factorials are a good example because the code, it really does lend itself to a recursive call. And so one of the keys that we're going to be using a lot here is this else statement. So let's just get this running first. And then after we've got it running, we can talk more about it. So let's see. And that's not quite going to work. I'm going to have to do this a little more piecewise. We'll grab that first, and we'll pop that in between our starting and stopping points. Give it a little bit of space just to make it look nice. That's where we're going to create a scanner. It'll probably want us to import a scanner. Yeah, it's just a Java utility. There we go. And that's actually getting our input right there, so that's good. And then it says, hey, by the way, I don't exist yet, so I'll just lean on the integrated development environment to go ahead and create that. And then looks like public static long. So now I can just kind of go grab the insides of that from Daniel's example. And Daniel has this as a long, so save that, Control A, Control I. Now, let's see if this runs. It's 4. 4 is 24. The reason I picked that, Daniel gave that, I thought, as an example in the book, 4 and 24. Now I can try 10. And it's 362880. Okay, now let's actually look at what this code is doing. So what it says is, hello, that's a print statement. I like that. Okay, creating a scanner. This is something we introduced in chapter 2. And so the name of the object is input, and it's defined using this class, and the constructor passing it system.in. And so now we've got our print statement. we get in. Now, if we were going to be more careful, we could try things like, you know, A, if you don't make a positive n, then make it do n again. But anyway, factorial of n is factorial of n. It says, and then it prints by. So this is a print statement, and this is just repeating this number from up here, right here, and then this is a function call. So what does this function call do? Well, it's right here. And so factorial of n, and it says if n is equal to 0, return 1. Else, return n times do another function call. But this time, take 1 off of n. And so this is the recursive call. And so it keeps popping along until n gets down to 1. And then, or n gets down to 1, and then n minus 1, when it calls this, it'll pass in a 0, and then it says if n is equal to 0, then it returns 1. And when basically the vision that I have in my head of this is, you can imagine a spring getting wound up, and so when we say 4, what it's going to do is it's going to start out with 4, do a function call. Now it's going to call it with 3, function call 2, function call 1, function call, oh, now we can return that 1. It goes 1, 2, 3, 4, and then it comes out. And so it's very efficient or very elegant, but the coding does not get complicated, but it does make your computer start to work a little bit harder. So let's do 15. Okay, it does it relatively quickly. Let's do 100. Factorial of 100 is 0. So I think that probably a rounding error has happened there. And so what we're going to do is, oh, come on, too far. What we're going to do, since that had a problem, is then we're going to go ahead and we're going to work through exercise 18.1, the big integer class, to do the factorial of a large number and implement the factorial using recursion, and then write a program that prompts the user to enter and display its factorial. Okay, so this is the problem we're going to work through, but we're going to do that in a separate video. I just wanted to introduce the first listing and kind of wet your whistle a little bit. But anyway, recursion is interesting. You can do a recursive or non-recursive algorithm for many different things. Many discrete structures books, discrete mathematics books are also going to have sections on recursion. It's just an interesting concept. The idea is you write one generalizable step, and you can basically use that step repeated over to do a very large number of things. So it's a very efficient way of problem solving, and I like it a whole lot. I just wanted to get you started. So with that, thank you all for your time, and enjoy the afternoon. I appreciate you being here with me.